Hello everyone, welcome back to my channel. This is Hitesh Agarwal, and today we are going to work on configuring our layer 3 network. So today's agenda, uh, introduction to today's protocols. What we're doing today, we're going to start with configuring static routes and floating static routes. After that, we're going to move on to default routes. Default routes, it's a different kind of routes. They don't belong with the floating static routes, and they don't belong in that category. And then we're also going to talk about NAT or PAT in a sense. Um, so yeah, let's get straight into it. Let me pull up the topology and everything. So we are back here. Today we're working with our NAT cloud up here, and we're working with our ISP router and our main site 1. Um, First things first, we because we're doing static routes and floating routes, we're going to work with these 4 devices. Basically, static routes, to explain what static routes are. Um, SW1, I'm gonna do this with some example. We know that SW1 can see 2 networks or 3 networks right now. It sees the network to R1, it sees the network to R2, and it sees the network to SW2. What it does not see is the network that SW2 shares with R2, and the network R2 shares with R1, and the network R1 shares with SW2. So basically, that's one way to explain what static routes is. Static routes help that particular device know about all other networks that it can reach within its own, well, in its own network. Static routes basically tell that device that, hey, there are more networks and this topology that you can reach through this device or through this device. Floating routes are basically a backup route to that static route. So let's say, and I will show you the static routes as well. So let's say on SW1 we add an IP, we add a static route for 192.168.60.4, and we say that, hey, to reach this network, go to R1. That's our main route. But what if R1 goes down? How we're going to reach that network through R1 if it goes down? That's when floating routes come in. And floating routes, we add another floating route saying, hey, in case the first static route to that destination is down, use this route to get to that network again. So we add another route, and this time we say to the destination of 192.168.60.40, go to R2. And that's basically a backup route to that network. That's basically what it is. To explain default routes basically a way a way to get out of your own network. So once we configure static routes and NAT as well. After that, we'll configure default routes. Sometimes they will automatically pick up default routes, but sometimes they don't. PAT or PAT, well, I'll explain later, but NAT, I want to explain first. NAT basically stands for Network Address Translation. What it does is it basically translates private IPs to public IPs because we only have so many public IPs. We have very limited amount of public IPs. We cannot statically configure every device in the network to have public IP. So we use private IPs, which cannot be routed globally. So basically, on the edge devices, in our case, our edge devices is R1 and R2. These two will be NATing our private IPs to public IPs. To explain PAT, PAT is basically, so there are 3 different kinds of NATs. The first NAT is a static NAT, which means one private IP to one public IP. Then there's a dynamic NAT, which is either one private IP to one public IP or a pool of private IPs to a pool of public IPs. Then there's PAT, which is port address translation, or I like to call it PAT, but sometimes people call it PNAT and stuff like that. PAT is basically many it's a lot like dynamic NAT, but it works on port number. So it basically assigns a port number to a private IP and handles all the exterior communication throughout. PAT is mostly used in today's networks, so that's what we're going to use as well. So let's get straight into it. We're going to start with configuring our ISP and our R1, R2. We haven't touched R1, R2 yet. We're going to figure out all these networks, SW1 and SW2, and then we'll move on to static routes, default routes, and PAT. So I have loaded up all of our devices here. I'm going to work with these devices today, and I also went ahead and made some scripts because this could take a long time for us to configure manually. So um, yeah, let's see first confirm G00 and G01 is this one, 60.18, 17 I believe is 16.16. Yeah, yeah. Okay, so that's the one. Issue. Let's just make sure that we do have some configuration. Well, as you can see, we already have why do we not have all the VLANs? Oh, there we go. It was just didn't show up properly. Okay, so today, for our script, we're going to configure in G00 and we'll configure in G01, which are connected to the other sides of the network. So I'm going to copy this, and it's just very simple configurations. We have done this multiple times on videos, and there's not much to explain here. Oh, wow. Okay, so we might have to wait for that. All right, we're waiting for that. And same thing here. I'm gonna copy the script that we have that I made um, for this. Okay, so next we're gonna work with R1, do show IP int brief. And you can see we have all these ports that we're to work with, but we haven't configured any of them yet. So first things first. Okay, so right now we're going to configure int G10, G20, G30, and G60. Now you will see that this IP here is not matching others because this is a public IP. Because we're simulating this network, it does not actually go outside the network, outside to the internet. Not with this network, not with this IP actually. So we don't have to worry about using an actual public IP. It's only simulating a public IP. It's not an actual public IP. So let's configure this part. Um, Paste this all, and there we go. Same thing for R2. And there we go. Now, if you wanted to make sure everything is pinging through, we could try ping around the network, or we could ping the actual network itself, and we should get replies back. So in this case, if you were to ping 60.4, 60.12, 60.0.8, so if you, let's start with 60.0 from SW1, and if you do ping 192.168.60.0, we should get replies back from 60.2. Um, Yeah, so you got one back from 60.2. Let's also do this no IP domain lookup on all devices because this will stop the DNS server lookups, and we do not want that right now, as it can cause slowbacks like this. Let's wait for this to finish up. If we do a do ping from here, if we do a do ping 192.168.60.8 thing, that is network now, 60. Yeah, 60.8. You should get a reply back from 60.10. Back here, 60.12, looping 60.12. You should get a reply back from 60.14. There we go. And if you want to ping 60.4 and 60.16, 60.4, 60.16, do ping 192.168, 60.4, and do ping 192.168, 60.16. We should get replies back. 60.14, as you can see, we got replies back. Now let's also do no IP domain lookup here. 60.16. And this is basically, we're just making sure that we have access to the network, or we have full connectivity between the network. So now we've configured the actual interfaces, and now let's start reconfiguring routes. So right now, if I were to show you something, if I was to do a do show IP route, you'll see that we have these many routes here. We can see 60.4, we can see 60.12, and we can see 60.20. But we cannot see 60.0, we cannot see 60.8, and we cannot see 60.16. That's because it does not know where those networks live. So that's what static routes is. We're basically informing this router, and we're telling where that network lives. Also, another thing you could see that it does not know about the VLANs. It does not know about the VLAN network here because it's not directly connected to it, so it does not know all the networks that's inside the network. So we're also going to tell that router about those networks. So I also made another sort of routing script. You can see um, this is basically what we're telling that um, router, that hey, 60.0, if you want to reach, because we cannot see 60.0 here either. We cannot see 60.0. We cannot see 60.8, and we cannot see 60.816. So we're telling that hey, 60.0 lives on this network, 60.13. So on the other hop, if you want to reach 60.0, go to this IP. And same thing for 60.8. If you want to go through that, it lives on 60.6, and 60.16 also lives through 60.6. That's a normal static route. Here you will see the same thing, but with these numbers at the end. Now this number, I will show you what it means in a second. Let's first add this route. So if we copy this route and we paste it in, and we do show IP route again, you'll see now we have these networks. Now we statically add, and you can also see the static route symbol here. So we statically added 60.0, we statically added 60.8, and we statically added 60.16. What that number means here, the number 10 refers to this number over here, 1. By default, static routes have an administrative distance of 1. In case this router was, or in case this link, in case 60.6 was to go down, and there's no other way to get for us to get to that network, we basically look for the next available route with a higher AD, administrative distance, and that would be this one. So let's also add this in, and let's do another do show IP route to see if it got added. Well, we see that it did not get added because it is never going to get added to the routing table because we still have an active connection with the previous route, previous static route. So until that router goes down, until that network goes down, that connection to that router goes down, the floating static routes will not take over. Um, so now same thing here. We're adding the static routes to the VLAN IP addresses, VLAN networks. Same thing on router 1. I must also add that this is not best practice for routing. There is another form of routing that I'm going to cover later, which is basically dynamic routing, and I'm going to explain that later as well. So here we configured all of this LAN interfaces. So let's see do show IP route and see if we have these routes. And as you can see, we do have these static routes for 10.0, 20.0, 30.0, 40.0, 50.0 for all the LAN IPs. Next, let's do R2. Same thing. We're going to do same configuration on R2 because it's also an exit router. So here we go. Paste. We do show IP route. And we see all of these IPs. We see all of these site routes. Next thing we do on SW1 and SW2. Now we're just telling SW1 of the other networks that live on the topology because SW1 does not know about 60.4, it does not know about 60.8, it does not know about 60.20. So we're gonna tell that, right? We're gonna tell SW1 about these networks along with the floating static routes for those networks. Other ways for that to get around. So let's go ahead and do that. Before, let's see do show IP route. And we'll see that we do not currently know about those networks. Yeah, here we go. So we only know about 60.0, we know about 60.12, and we know about 60.16. We don't know about 60.4, .8, and .20. So we're going to add information about that. Oh, we didn't copy it properly. Okay. And if we do show IP route again, we should see more static routes. So here we can see 60.4, 60.8, and 60.20. All right, same thing for SW2. Can only see some networks right now, the one that is connected to. We're going to go ahead and add all the other networks. So right now I can only see, let's see what networks you can see right now. So right now I can only see 60.0, 60.8, 60.20. So we're going to inform it about 60.12, 60.4, 60.16. So let's go ahead and paste. Do show IP route. And now it knows about all the other networks. It knows about 60.4, about 60.12, and it knows about 60.16. All right, so that is static and floating static routes, how to configure them. Like I said before, this is not best practice. I would not recommend doing this in an actual network. In an actual network, we would use another technology known as dynamic routing. This is static routing. We're going to use dynamic routing later. I'm going to explain what it is. And yeah, so today's tutorial was only static routes. And so let's move on to the next part. Next part we're going to talk about is default routes. Default routes, to configure default routes, we should first actually configure our ISP as well. So let's configure our ISP. Um, did I have a script for ISP? I don't think I did. So let's actually do that manually. So int g10 IP add 198.1.1.254 no shop, and if you do ping 198.1.1.1, there we go, and int g20 IP add 198.1.2.254 no shop, and do ping 198.1.2.1 and int g00 or int g60, sorry, and IP add DHCP. No shut. And I'll explain why we need the DHCP address in a second. Let's first see if we get an IP address from the NAT cloud, which we should. Um, all right, there we go. We got an IP address from our DHCP side. All right, so the reason why we need the DHCP address is because we need to get out the network, and this is basically serving as internet. In a second, I will show you how we're going to reach internet. So now, on our ISP, if you were to ping 8888, it would have that. So that basically means that we have internet on our ISP router. In real life, you will never actually configure an ISP router because we never actually touch the ISP routers. So in an actual network, we would only work with our network. We would only work with R1 and R2, our side 2 R1 and side 3 R1. We would actually never work with ISP, or we would never work on ISP. So that's what it is. To show, if you do show IP route, you will see that this line here, gateway of last resort, is 192.168 network everything. That's basically a default route. This is what a default route actually looks like. And if you look at the symbols here, you will see a static with a asterisk sign. So if you see an S sign here, S means static, and we see dash as candidate default. So it's a default route that it automatically added when we added that network. If you were to check R1, do show IP route, and as you can see here as well, we don't have one right now. It just is not set. So if we do this again, you can see that we still don't have it, but we need to add a default route. It's basically we need to add a default route for our LAN, for our VLANs to reach internet. So if we do IP route, and to add a default route, this is the configuration, IP route quad 0, and the next hop IP address, which is 198.1.1.254. And if we were to do show IP route again, you'll see gateway of last resort is 198.1.1.1.254 to that, and we also have a default route here. Same thing over here. We don't have one right now. We're going to add one to our R2. So IP route quad 0, 198.1.2.254, and do show IP route. You'll see that we have a default static route, and that's basically what a default route is, a one way to get to the net, to get outside of our network. To ping, if we were to see if we can ping internet, we should not be able to ping internet right now. Um, it will try, but it won't reach anywhere because we haven't configured natting yet. And this is a bit of a weird topology, but this is what we have to do. In an actual network, we would only need to configure NAT on our edge routers. But today I'm gonna show you guys some more stuff. And we're gonna configure NAT on our ISP first, and then we're gonna configure NAT on our um, site routers. So let's go ahead and do that. Let's first do NAT on our ISP. To configure NAT, we need to configure first an access list. So we can configure access list. Access, oh, sorry, we are still in interface mode, so it's not gonna work. So we're gonna do access list permit, access list one permit 198.1.0.0. And if you do a question mark here, we see and it needs a bytecode bit. So 0.0.255.255. So this access list is basically permitting the entire of 198.1.0.0 domain. That covers 198.1.2.0. In future, we're going to add 198.1.3.0 and 4.0. So that will cover that network. And now this is how to configure static NAT, or sorry, PAT, not static NAT. We're not doing static NATs. So IP NAT inside source list one interface G60 overload. Overload is basically the version of PAT. So if you want to configure PAT, we add overload at the end of the statement. Now we have configured NAT, but we have not configured one thing, is to tell the router which interface is outside interface and which side is inside interface. So int G60, G6/0, IP NAT outside. No shut. Int G10, IP NAT inside. Int G20, IP NAT inside. No shut. Now, if you were to do a do ping 198, oh sorry, 8888, source, if you do a source ping 198.1.1.254, we should see that we should be able to reach the internet through the LAN, through the inside interfaces. So now, if you look back at the topology, we have configured NAT on these two interfaces, and we've configured, and now what we need to configure is NAT on these two routers to basically allow traffic to pass through to the internet. So if you come back to site one, we do an access list one permit. Now, because we have so many addresses here, I think we're just going to do 192.168.0.0. And same thing here, IP NAT inside source list one per interface G60 overload. And we need to manually go and configure those interfaces as inside. So do show IP in brief. So we have these three interfaces that we need to configure as inside. So int range G1/0 to 2/0 or 3/0, sorry. Oh, I don't think it would work. Interface range would work on this specific router. So IP NAT inside, int G20, IP NAT inside, int G30, IP NAT inside, int G60, IP NAT outside, etc. Now, if we were to ping, if we do ping 8888, we should see internet. There we go. I'm going to do the same configuration on um, R2. So access list 1 permit 192.168.0.0 and IPNAT inside source list 1 interface G60 overload and int G10 IPNAT inside int G20 IPNAT in int G30 IPNAT in int G60 IPNAT outside and do if you do ping 8888 you should have internet. There we go. If you let's try source pinging it through one of the interfaces. So let's pick one interface, local IP 60.0. So if we do ping 8888 source 192, 192.168.60.6, we have internet on the LAN interfaces as well. So now what we can do is we can try and pinging from the switches to see if we can get to the internet. So if we do, let's see the IP interfaces here, show IP in brief, and we have, let's ping from a LAN interface, shall we? So do ping, I'm sorry, ping 8888 source 192.168.10.254. I think one other thing that we have to do is we haven't added a default route here. So actually, let's check that. Show IP route. Wow, can't type. Yeah, so we haven't added a static route, default route here. So let's add that. So that's actually a good demonstration of it. Again, because we don't have a default route outside to go outside the network, we cannot ping to the internet. That's basically what it means. If you do not have a default route going out to the outside network, you won't have connectivity to the internet or any other services available anywhere outside your own network. So if you were to ping or if you were to do a default route here, it would be IP route quad zero. And another way we could do default route is through interfaces. So I'm going to say gig 00 G0/0. So if we do show IP route, we should see that. Now, what we should actually be doing is doing it through IPs because that's more reliable. So actually, let me just change that to an IP interface. So R1's IP 60.14. So let me change that actually. We do a no IP route here. IP route 192.168 60.14. Do show IP route. And we should have a default now. There we go. So now if we were to ping again, do ping 8888 source 192.168 10.254. We should see some pings going out. Okay, so we don't have that. Let's see. Okay, so I think I found the problem that we have. In our access list, we did the wrong IP. We did 198.168. But that's not the right access list. So So now access list one. Access list, we should do access list one permit 192.168.0.0.255.255. And now if we do ping source, do ping 888 source 192.168.60.14, we should have that. So let's try pinging again here, and I do. So that was the main issue that we had. Same thing here. We have not added a default route, so IP route quant 0, quant 0, and the next hop is .10, I believe. So let's check do show IP route .10. So yeah, 192.168.60.10, and do ping 888 source 192.168 10.253. There we go. So now if we were to go on our devices here, and if we were to ping again and again, one second, let me just get the terminal. And if we were to do ping, let's see if we have an IP, we do. And let's see, ping 8888, we have ping to the internet. So now we have internet. If we were to do trace route, trace 8888, trace is not a recommended command, trace RT, trace route. Let's see. Okay, so here we can see. So at first, 192.192.168.30.254. That is the the default gateway. Then it went to 6.14, and it went to the public IP 191.1.254, which is our ISP side of network. And then it went to the public IP. Well, it's still a private IP, but this is a public IP from our perspective. And then it went to outside. So that's how basically this entire thing works. So that was our today's concept. We did PAT, static routes, default routes, and fully static routes. Next video, we're going to work on dynamic routing, and we'll also adjust our we'll also adjust our NAT. I think it should not matter in the sense, it should not matter. NAT should still be working once we switch over to dynamic routing. But just to confirm, we will mess around with NAT again and confirm we still have um, connectivity. So before we sign off today, we should do write to the memory, write the configurations to the memory. So when we come back, it is saved. Let's confirm. It's a lot of configuration that they're writing to their memories successfully. All right. I'm not sure about what this is, but it's a CPU hog, so it's hogging the CPU a lot. That's fine. Yeah, so starting next video, we're gonna work on dynamic routing. We're gonna get rid of all of these static routes, except this one. We could actually work with this through dynamic routing as well, but it's not as it's, uh, it's not worth it in a sense. So we're gonna get rid of all of these static routes that we have in the next video, and we're gonna configure dynamic routing. And I'm gonna introduce you to some dynamic routing protocols as well. So thank you guys for watching. This is Desha Agarwal, and I'll see you guys next time.